So, if you've ever worked with inheritance in Java, you've been right on the edge of a concept that truly unlocks its real power. Today, we are diving deep into upcasting and downcasting. Trust me, this is the key to writing code that's not just functional, but flexible, powerful, and genuinely smart. Let's get right into it.
Here's the game plan for today. We're going to start with a concept you already know, something familiar. Then, we'll climb up the ladder with upcasting, see the little wall we hit with its limitations, and then discover how downcasting is the perfect solution to break through it. We'll wrap it all up with a quick side-by-side recap to make sure it all sticks.
All right, before we get into the wild world of objects, let's start with the absolute basics. We're talking about something simple, changing a basic variable from one type to another. This whole idea really comes down to one core concept, typecasting. It sounds fancy, but it's not. It's just the act of converting a value from one data type to another. You know, like turning a number with a decimal into a plain old whole number.
Check out this super simple example. We have a double, d, which is 4.5. Now, Java is smart. It won't just automatically cram that value into an integer, because you'd lose the 0.5, right? But by putting int in front of d, we're basically telling the compiler, hey, I'm in charge here. I know some data might get lost, and I am totally okay with that. And just like that, I becomes 4. The 0.5 is just gone. Okay, so that's easy enough for simple numbers. But what happens when we step into the big leagues of object-oriented programming? Can we really cast an entire object into the shape of another one? Well, the answer is a huge yes, and honestly, it's a total game changer.
To see how this works, we need a really simple inheritance structure. So for all our examples from here on out, just imagine we have class A, the parent, and class B, the child, which extends A. Think of it like a parent animal class and a child dog class. Every dog is an animal. That is a relationship is absolutely crucial. So let's kick things off with upcasting, and yeah, the name pretty much gives it away. We're moving up the inheritance tree, going from a specific child class to its more general parent.
This one little line of code, this is the heart and soul of upcasting. Using our example, this would be like writing animal myAnimal equals new dog. See what's happening? On the right, we're creating a brand new dog object. But look at the left. We're storing it in a variable, a reference of type animal. We're holding on to a specific thing in a more general way.
And this breaks it down perfectly. The reference type, A, or animal in our case, is like the label you put on a box. The object type, B, or dog, that's what's actually inside the box. With upcasting, the label on the outside is more general than the specific item tucked away inside.
And this whole process is what we call upcasting. The best part? It's implicit. That means you don't have to do anything special. Java just does it for you automatically. And why? Because it's always safe. A dog will always be an animal, so Java is totally cool with this conversion, no questions asked. But of course, this amazing convenience does come with a small price. When we generalize an object by upcasting, we gain a ton of flexibility, but we also lose something in the process. Let's see exactly what that is.
So let's think about this. We have our object variable. Its label, its reference type, says it's an A, but we know, deep down, it's holding a B object. So, which methods can we actually use? The ones from the parent, the special ones from the child, or maybe both? Let's say our parent class, A, has a method called show1. If we call object show1, it works, no problem at all. That's because the compiler looks at the reference type, the label on the box. The label says A, and the compiler knows that anything that's an A is guaranteed to have that show1 method. But now for the twist. What if our child class, B, has its own unique method, something special called show2? Well, if we try to call object.show2, bam, we get a big fat compiler error. Even though the actual object in memory is a B and knows exactly how to perform show2, we can't get to it through this parent reference.
And here's the golden rule, the thing you have to remember. The compiler makes its decisions based on the reference type, not the object that's actually there. As far as the compiler is concerned, object is an A. The A class has never heard of a method called show2, so it throws up its hands and says, nope, can't do that. The parent just doesn't know about the special tricks its kids have learned. So we've hit a roadblock. How do we solve this? How do we tell the compiler, hey, I know the label says animal, but trust me on this one, it's actually a dog inside? Well, that, my friends, is exactly what downcasting is for.
It's like a simple three-step process. First, you create a new reference variable, but this time you make it the specific child type, like bobj1. Second, you take your original parent reference, obj, and you explicitly cast it by putting b right in front. This is you telling Java you're sure. Finally, you assign that newly cast object to your new child reference. And here it is in action. bobj1 equals b_obj. That little b part, that's the downcast. It's explicit, you have to type it. And now, because our new reference obj1 is of type b, the compiler is happy. We can finally call obj1.show2, and it works perfectly. We've gotten access back to all those child-specific methods.
So to put a formal definition on it, downcasting is just moving down the inheritance tree. It's an explicit, manual conversion that takes a general parent reference and turns it back into the more specific child reference that it truly is.
Okay, we have covered a ton of ground. Let's pause and lock all this in with a quick recap. Seriously, this is the stuff you'll want to remember for any coding interview or exam you've got coming up.
This table sums it all up beautifully. Direction: upcasting goes up, from child to parent. Downcasting goes down, from parent back to child. Syntax: upcasting is automatic or implicit. Downcasting is manual. You have to explicitly write the cast. And finally, the purpose, the whole reason we do this. You upcast to generalize and make your code flexible. You downcast to get specific and access those unique features.
But the most important thing to get is that these two are a team. They work together. You use upcasting to treat all your different objects, your dogs, your cats, your birds, as just one big group of animals. Then, when you pick one out and you know it's a dog, you use downcasting to tell it to do something only a dog can do, like bark. And that leaves us with one final big question to think about. Now that you see how we can treat an object as both a general thing and a specific thing, how do you think this very mechanism, this ability to move up and down the class hierarchy, becomes the fundamental key that unlocks one of Java's most powerful features of all, polymorphism? That's something to chew on. Thanks for tuning in.